I just talked about all these things that are needed to be measured: CEC, pH, nutrient availability. None of it means a hill of beans if you don't actually go out and quantify it. This is not something that you're just going to be able to smell the soil and say, I got an acidic soil, I know exactly how much phosphorus or lime I need to deal with. You have to take a soil sample. I think it's as important as gardening as it is in crop production. It's that, yes, you can buy just elemental sulfur. Soil sampling for me is like doing finances for the family. It just kind of tells you where you are. You guys are going to be master gardeners. You're very active. You're very aware of what you're doing. This is just another piece of information that lets you know kind of what's going on in your soil and kind of brings you together with a little more intimate knowledge of what's going on. So this is a video Terry had me do about taking a soil sample. So we'll probably have to go through an advertisement. Nope, good.
Why someone would consider taking a soil test, or in this case a chemical properties test, is if they want to get some type of assessment of what is going on in their soil. This is really important if you're establishing a new garden. If you have an old garden, things aren't quite working out the way you thought they would be, this is a great way to troubleshoot and find out more information about what's going on in your soil. So what and how you garden does determine where you'd want to take a sample. So if you had something like blueberry bushes, those are going to take different type of fertility and nutrient management than something like a tomato garden or brassicas, that kind of thing. And so you would want to manage that type of soil differently. And one of those key things for management is knowing the soil pH. And you really have to take a soil sample in order to get that information, so then you can use that information to change your soil so that it can better grow what it is you're trying to grow, say that blueberry or those tomatoes. You need a couple tools first if you're going to take a proper soil sample. More than likely, homeowners, this is not something you would have lying around. They cost several $100s, and that's a soil probe. Your local lawn and garden store might have them for you to borrow and use. Farmer cooperatives certainly have these. Local farmers would have them. But if you don't have access to something like a soil probe, you can get by with other tools like a common spade or even a bulb planter. So once you've got your tools and you're ready to take the sample, you want to then go to your areas that you're going to manage uniquely. So if it's a vegetable garden, that's your area that you'll be sampling. And so you're going to want to take multiple different samples from that area. You don't want to just trust one number. So take multiple, what we call sub-samples. You compile them into a bucket, you mix them up really, really well, and of that you only take a small handful, maybe a pint or less, and you take that and you send that to a soil lab. So a critical thing along with taking your soil is the depth to which you sample. And the reason that's critical is there's a higher concentration of those nutrients located at the top, and a lot of recommendations from different extension programs, be that Nebraska Extension or some other universities that have extension programs, they calibrate their recommendations based on a certain depth. So after you've sent it to a reputable lab for soil testing, they're going to give you a lot of different types of analysis and reports, and that would be the pH, things like buffer pH, your nitrogen content, your organic matter, phosphorus, on and on and on. A lot of different nutrients that are essential for crop growth, or in this case your vegetables or your flowers or what have you. The number one thing you're going to want to look at is that pH. And if it's too low or too high, there's things you can do and amend to your soil to remediate that situation, like lime.
Okay, let's get back to the talk. I want to make sure I get through soil physical properties and then some common issues that gardeners will face. So you heard from myself, I guess, in the video. It's critical to take a soil sample, but as critical is how you take that sample. You don't just take your probe, stick it once in the ground, send that off to the lab and say, I took my soil sample. That is not a good idea. It is, you could hit a hot spot in terms of nutrient, or you could hit a low spot, or you need a representative average.
Turn your lights back on.
Off or on?
On.
They are on.
Okay, that was just in the comment box.
That just tapped. I think they're referring. Does this help?
Yes.
Okay, that's lights off. So I'm in the dark here presenting, but it works. It works well. So take at least 10, 12 samples. So you take the probe, you put it in the ground at least 12 times, and put that in the same bucket, and you mix that up. And of that, what that's in the bucket, you send that into the lab, a portion of that. And most labs need like a pint of soil. I said depth is critical. And the reason depth is critical is because, like we said, the nutrients are concentrated at the top. If you ignore that concept and it doesn't matter how deep I sample, it's going to have dramatic results on what you get back and to what you would think you would need to do to manage. And that affects everything from pH, CEC, to all your other nutrients. And so if you look at this chart, if you follow my mouse here, I took a sample every 2 inches, and then what value was represented, in this case it was phosphorus, at that depth of soil. And so at this point, we went 0 to 2 inches, and that soil sample had a value of close to 57 parts per million of phosphorus. My second sample was 2 to 4 inches in depth, and its average was 7 parts per million. And I did this in 2-inch increments, and now we're like 2 parts per million, 1 part per million, 1 part per million, all the way down to 10 inches, just to kind of demonstrate. So when you're sending in something that's 0 to 6 inches, which is a lot of what surrounding states have for their recommendations, you do a sample from 0 to 6. University of Nebraska, at least for our agronomic crops, we recommend 0 to 8 inches for very specific reasons. So in the eastern coast, like Cornell, they do a lot of horticulture research. I think they are 0 to 8 as well. So that's important to tell the lab what depth you're going, because they will make recommendations based on that. Looking at the same chart, if I would average each sample as if it was composed of every sample before it in terms of depth, it would look something like this. So if I only average the top 2 inches, it's the same value because there's only 2 inches represented. If I average the 0 through 4 inches, look at how elevated my soil test value is. And as I go down to our recommended 8 inches at Nebraska, we would have something like 17 parts per million represented from our sample. But if I went just 2 inches shallower, I would tell myself I have 22. If I went 2 inches deeper, I would tell myself I have something like 13. Right now, it seems like I'm splitting hairs, but if you're inaccurate with certain nutrients, you can really skew the results and cause yourself a problem when you're trying to interpret that and say, okay, what do I want to do to manage this? How much lime do I put on? Well, depth matters. This was phosphorus, but it would be equally important for something like pH. I'm going to go to a different app to explain the soil test. So when you get your soil test result, we happen to send into Midwest Labs. I'm not trying to advocate you send to Midwest versus Ward versus Olson versus Harris. There's a lot of good reputable labs throughout the state. I recommend one you have a preference for and stick with it. They're all very good. A soil probe is the best way to maintain a constant depth and constant volume. Bulb planters are a supplement that you could use, but oftentimes they're tapered, and so their volume's not quite the same. I would say that it should still get you close enough, as long as the taper is not like a sharp triangle. But if it's just barely tapered, that should give you a good enough result. Because I'm not going to sit here and say go out and buy a $200, $300 soil probe for your garden. I think that's ridiculous. Find somebody that has one, talk to a place that has one, or use something like a bulb planter. They're easy. A lot of them come with foot pegs now, so that's a good way to take a sample as well. If you look at this lab report, then this is what the lab actually sends back. You see a lot of different things going on. So for one, it identifies the sample, what it is, and where I took it. I took it at a depth of 0 to 6 inches in this case, and they put that down there. It gives me my organic matter, several other nutrients. But when I look at a result, the first thing I go to is pH. Absolutely. I want to see pH, because if pH is out of the range, like we talked about probably for 30 minutes now, that's the number one thing I'm going to correct. This is how they list their CEC right here, and then the different cations that are dominating position on that cation exchange area. If I had a really low pH, meaning I need to raise it, they would put the buffer pH here. And then they give you a range of values. So like I said, organic matter, they give you a lot of different phosphorus tests. Use Bray P1, Olson, or Malick 3. These are calibrated tests for specific conditions, and you do not want to use something called Bray P2. They give that as an indication, but it's not something you would manage with. So you can basically ignore this. To me, it's not useful for any type of production. And it gives you these other values for other nutrients. Now, this lab, I sent it, and you specify, this is a garden sample, this is a lawn sample. That helps them when it's coming across their line to know how to calibrate their machines to prepare for it, because typically garden soils are much, much higher in a lot of nutrient fertility than a crop field is. Just because of the nature of the compost and what's being added to it, things aren't typically calibrated as much. And it's very rich, Jenny. I've never seen that much potassium in my life. Very salty. And this also has a lot of sodium, which is not a good thing, as we'll find out. But they will also give you a rating of very high, low, medium. They kind of give you a gauge of where are you, and most labs will offer some type of recommendation. And so if you didn't tell them you were doing a garden, they're going to give you some crazy recommendation for corn or soybean, and it's not going to make a lot of sense for what you're doing. So you take this soil test and you go to some type of a horticultural specialist, which I am not. I'm a soil guy. Or you can go to any number of extension guides. I know, Terry, you like to talk about the Knott's Handbook for Vegetable Growers. That's a good book that has a lot of different tables that discuss when is your soil low in potassium, when is it low in phosphorus, so on and so forth, and how much do you need to apply to your soil to get it up to the range that's sufficient to grow those plants. And so let me show you. Where did you go? So this is from Cornell. I found this to be a really helpful book. You can purchase it from them or get online access. The name of Terry's book is Knott's Handbook for Vegetable Growers. Is that right, Terry? It's green. Okay. This resource you're looking at right now from Cornell is an excellent extension publication for a lot of different horticulture. I have no shame in saying go to another extension service. We like to work together, and Cornell's done a lot of good stuff on horticulture, as have Nebraska and other states, but I'm just saying this is a good resource. And plus we have plenty of good educators in our state that can answer a lot of these questions. But it breaks down management for soil, and it also breaks down disease, weed, insect management, and for the numerous crops and what might be required for them. So this is where I would go to source how to deal with fertilizer needs for vegetable production, because it also says when's the best time to fertilize for timing. Because just kind of as an anecdote, excuse me, I'm stumbling on my tongue here. I was talking to Sam Wortman. He does not have an extension appointment, but he's a horticultural specialist. And you manage vegetables just a lot differently than you do in crop production. I think that's a no-brainer comment, but typically a lot of growers are covering a lot of acres and they need to do things up front. And so they might apply most of their nutrients up front, including nitrogen. In a garden sense, if you treated a tomato plant like you did corn, you would have a really bad result. And the reason is corn responds really well to nitrogen. But if you do that to a flowering crop that produces fruit, that could be to your detriment because it ends up creating a lot of vegetative growth from the plant. You get really tall plants, you get a lot of vines, but it starts to diminish your actual fruit production and flowering. And so there you would need to tamper down your nitrogen. So it's not always good to just have baskets of fertility if you want to think about it that way. It is good to pay attention to your soil samples and try to maintain more or less an optimum range based on what these books are saying. But as important as when you fertilize, keep that in mind. These books typically lay it out. So it might be important to add nitrogen later to the plant as opposed to earlier, after fruit is already set. So just keep that in mind. All of these things are dynamic and not static. Moving on. I mentioned a little bit about phosphorus tests. Their recommendations in their books will say what phosphorus test they're basing it off of. You'll see a lot of these that I have up on display right now. You'll see Bray P. These are scientists' last names. Bray P1, Olson, or Malick 3 are all nutrient tests that try to assess phosphorus. Malick 3 does a lot of other nutrients as well, but when you look at your recommendations, make sure you match up the soil test name with what the resource is referencing to what they recommend in terms of fertilizer, because these values are different. That's a critical point. Okay. Hopefully this works. I have so many things going on my screen here. And there's a picture of the Knott's Handbook right there. Sam Wortman also said this is a really great app that he uses when he talks to his classes. And it's available on iOS, Android, or Windows Phone. It's Yara, Y-A-R-A, and it's an application that just has nutrient deficiency pictures for various crops, vegetable crops, and then a little bit of snippet about that deficiency or when you might see it. And so let's go to tomato, for example, because it will give me a good lead into the next topic of physical properties. Where'd you go, tomato? There you go, alphabetical. Okay, so it gives a lot of neat pictures for the different types of deficiencies. So say you think you fertilized something correctly, you still want to be active in your garden looking for things that are changing. Are they disease? Are they nutrient? Can you still do something about it this season? Other than, there's normal senescence that occurs with growing plants at the end of the season. But this really helps isolate where you see the deficiency and what it looks like. And a really common one is blossom end rot, which creates this black discoloration at the base of the tomato fruit. And it says it's a calcium deficiency. And technically that's true. But if you look at just about any soil test in Nebraska, we are, unless you have sand, you are likely never deficient in calcium. It's the most prevalent cation we have in our soil. Okay. So why do we get these deficiencies? Because I guarantee I'm not the only one that has issues with this on my tomatoes. Maybe I am, maybe I'm not worthy to grow tomatoes, but I get this issue. And it's as related to getting that nutrient to the plant and into the plant as it is having that nutrient in the soil. So a soil test is trying to quantify what's in the soil, but it doesn't say what's accessible to the plant during the growing conditions that occur during the season. A lot of these nutrients require water to dissolve them to enter into the root and into the plant stem and into the plant parts to develop. Calcium is one of those. And so when I start talking about physical properties and soil that dries out and this and that, that's a soil structural issue, but it also involves, when we first started this talk, I said there's a three-legged stool that it takes to balance. There's the physical properties, there's the chemical properties, and there's the microbiological properties of soil. Every one of them is equally important, and they all interact together. You can't sit on the stool if you only have two legs. And so calcium can be induced because of issues with physical properties in your soil, be it compaction or such fluffy soil that it dries out, that you're not getting water to take these nutrients into the plant. So that's as critical as anything. If you raise the acid level of the soil, will it transfer that acidity to the fruit? I would think not. This is where I need to consult with Sam, but pH is it's just a condition in the soil. The plant still mediates what gets into the plant root. There's gatekeepers in the roots that say what nutrient comes in. And so if you got a pH out of such extremes, it can make it unlivable for the plant, but it's not going to necessarily change the dynamics in the plant. The exception to that would be when you overdose on certain nutrients, you tend to start concentrating those nutrients into the plant more than you would have because more of them are available and it's easier for the plant to then integrate them into its plant parts in what they call luxury consumption. It's not needed, but it ends up in the plant anyway. So that's the Yara app, Y-A-R-A. It's a free app. I'm not advocating for if they're selling anything. I'm just saying it's a good app to look for nutrient deficiencies.